In this session, I'm going to present Unbound Core's solution for authentication. Authentication of humans via mobile or workstations, how it works, and what its main benefits are. Let's begin with the main problem that we're trying to solve, which is human authentication. So we know that passwords alone are problematic, and we need multi-factor authentication. The problem is that deploying multi-factor authentication with existing solutions is very, very problematic. So let's look at the existing solutions out there. One is hardware tokens. Okay, so we provide the user with some physical device that enables them to authenticate. That could be a one-time password generator, or it could be a smart card, although that's even more difficult. Let's think of one-time passwords for the moment. So the problem with this solution, first and foremost, is that it's extremely painful from an operations perspective. You need to take this one-time password device with you everywhere you go. If you need it to make bank transfers and you go on vacation, then you actually need to take that with you, and you forgot, it's a problem. I once had a situation where I was on vacation. We needed to make a bank transfer for employees' salaries, and I didn't have it with me, so I had to call my son and tell him where to find it in my bag, in my office, and take it out and read the one-time password to me, let alone the security issues that I left it lying around somewhere when I wasn't even at home. These are extremely painful to use and to deploy from an enterprise perspective. Beyond that, one-time passwords are also problematic because of social engineering. We know that people can be tricked into giving up their one-time password, like being called by an administrator and saying, listen, I need to synchronize your one-time password device. Please give me the next number so that I can verify that it's actually all working. And people are naive and actually give it up. Another solution which solves a lot of the usability issues but not the security issues is to use what we call SMS Otp. So here, instead of having to walk around with a separate device, I have my phone and I get an SMS to my phone with a one-time password. That's obviously much, much easier to use than carrying around a device, much easier to deploy. I don't need to install any software. It's an incredibly easy to use solution. The problem is that it has a lot of security issues. If we come back to the social engineering side of things, people will, I'll receive a one-time password. I don't know where it's from, and I just got some code. And then I get an SMS from someone saying, sorry, by accident, my one-time password got sent to you. Can you just please send me that number that you just got? And this is a random number that has no relevance whatsoever. So I can, of course I can give it to somebody because it doesn't mean anything. The problem is that what's actually happened behind the scenes is they've gone into my account, and in order to authenticate, they've been sent the one-time password. It goes to me, and I've just given it up to them, and then they can go and take over my account. I have a friend whose son in high school actually had his WhatsApp taken over by someone using this exact strategy. They took over his WhatsApp and they did a lot of damage. They changed his profile picture and sent messages to all of his friends, and this is very traumatic for a teenage boy. On an enterprise scenario, this is of course much, much worse than just being traumatic and emotionally difficult. This is actually a very powerful way to get into people's accounts. Another attack on SMS Otp is what we call SIM swapping. And a SIM swapping attack is very simple but very sophisticated at the same time. Now let's think about what happens when you lose your phone and you have SMS Otp. Then, well, in general, if you lose your phone, you need to call up your phone provider and get a new SIM. And that SIM has to be associated with your phone number. So what an attacker does is actually calls up the phone provider and says, hi, I've lost my phone. They're talking somebody else's name. I've lost my phone, or my phone fell down the toilet and it's broken and I bought a new phone and I have a new SIM. Can you please associate my phone number with this SIM? And they start asking questions that are very hard to answer, like what's the name of your dog, what high school did you go to, and what's your birth date, and all of that information is on social media. So an attacker, that social engineering attacker, has all that information already and pretends to be me, and then they succeed in doing that association. As soon as that happens, my phone stops working. I no longer have internet access. Now, most of the time I don't know why, and it takes me a while to call my provider and find out. But even if I know why, I'm afraid that now actually I'm being attacked, it's a problem. I may be away from home and I don't have any access to any other phone. And even if I do, I now have to convince the phone provider that they're the attacker. Maybe I'm the attacker. Okay? So, and it takes a long time to recover from that. Meanwhile, they've got into my account because now they've gone and said, send me the OTP, and it's sent by SMS to my phone number. But my phone number is now associated with their phone, and therefore they get the OTP and they can go into my account. Because the SMS OTP is very comfortable to use or much easier to use than a hardware token, but it has a significant problem in this social engineering and SIM swapping type of attack. The next type of solution, therefore, is to use my mobile phone itself. And here the difference is that instead of relying on my phone number, we rely on a cryptographic key that's inside my phone. So just like the hardware token, which has a key inside, the mobile also has a key inside. If someone steals my phone number, it's not going to make a difference because they won't be able to steal the key, which is on my mobile phone. And that key can be used to generate a one-time password or some other cryptographic secret. It can even be a signing key for transaction signing, which is even stronger. And that solves a number of problems. Number one, if I'm actually signing on transactions and it's not a one-time password, I can give up to someone else. So I'm now not vulnerable to social engineering. I don't have anything I can read out or give to someone. It's actually a long cryptographic string which is automatically sent when I do the transaction. And the second thing is I can't do these SIM swapping attacks. Another very big advantage is the fact that I carry my phone around with me everywhere anyway. Now, obviously this is a usability advantage. Right? We talked about the challenge of these hardware tokens and always having it on me and how we deploy them. My phone is always on me and we don't have to deploy it. I have my phone. And that's also a security advantage because I don't leave my phone lying around. A hardware token I can leave lying around and then somebody can use it when I'm not looking. But my phone is always going to be on me. The only problem with this solution is that mobile phones are inherently insecure devices. And there are more secure and less secure devices, but in general, people download all sorts of apps onto their phones. And a lot of those apps are actually designed to steal information from users. It's very common for stealing location and other information. And also, if I really want to attack a system, what I can do is write an app, which is a great fitness app, and I can pay a celeb who's everybody knows to prepare this fitness app for me, and I can offer it for free. I'll get millions of downloads very, very quickly. The cost to me as an attacker is not that great. The reward can be huge when all these people download this app, but this app actually goes and steals, for example, secrets which are sitting on people's mobiles. And therefore, the problem with this is that this key is very vulnerable. And I guess you can assume from what I'm saying is that this is where Unbound Core can help with what we call the virtual Enclave SDK for mobile, which is we can protect that key via MPC by not having it in any single place. So in terms of usability, in terms of security that I take the device with me, this is the best possible. The only problem is that that key is going to be vulnerable. So how can I protect that key? And that's what the Unbound's virtual enclave does. So instead of having the key on the mobile, we're going to split that key between the mobile and a server that's in the cloud or in the organization's data center or something to that effect. And when a user needs to carry out an operation, which is to sign on a transaction or something to that effect, then that happens without the key ever being brought together using the secure multi-party computation, or MPC, that we explained in the first session. So using MPC, the key is no longer vulnerable on the mobile, and in fact this sharing of the key changes at every single operation in this setting, and now I get the best of all worlds. I can use a device that everybody has with them anyway. it's easy to deploy, it's easy to use. For users, it's even better. They don't even see anything. If we think about, SMS Otp is really easy. It's on my phone. The problem is that, firstly, there are sometimes it's hard if I'm traveling overseas, I won't necessarily always receive SMSs, but also there's an annoying thing where I have to switch apps. Okay, so I'm using an OTP app and I need to get the OTP, so I'm using an app to log in, I get an SMS, I have to go to look what the messages that I received and switch back to the other application. It's quite painful. It's not terrible, but it's quite painful. But Unbound's Virtual Enclave SDK can be integrated into the mobile app of the organization. And I'll give you a concrete story of one of the larger banks in the world that is using this for millions and millions of users for their banking app. And this is a very powerful story about the benefits that Unbound brings to customers. So there was the business unit, the mobile business unit in this bank, for years have been pushing to increase the functionality of the mobile banking app. Increasing the functionality, means can you transfer funds, not just look at your bank balance? How much are you allowed to transfer? What's the limit on transferring via your mobile app? And the security group in this bank was pushing back and not allowing them to do that because of the inherent risk of a mobile. We know that a mobile is insecure, so you want to allow users to transfer large amounts of funds from their mobile. How can we be sure that this hasn't been taken over? And this battle between the business unit and the security group went on for years, and the solution was actually Unbound. When Unbound was brought in to protect the key on the mobile, the business unit could integrate this strong authentication, so this strong two-factor authentication, using the key on the mobile along with the user password or a biometric, or whatever other authentication is available on the phone, then that enabled the security team to sign off and say that's fine. And the business unit got really the best of all worlds. Not only did users not have to type in a long password anymore, which anyway wasn't secure enough, they could use the native biometric authentication of the phone. And the protection, though, was related to this strong cryptographic key that was protected using Unbound Secure Enclave. Users had better usability, and there was high security. And that's very unusual in this space. Very often, security and usability is sort of at odds. The more I increase security, the more I harm usability. But here, they went together, and we actually got a really best of both worlds situation. Beyond that, an important aspect when we start thinking about using a mobile for authentication, whether it be for the app, for our banking app, or for customers or employees, one of the big issues that arise is that many different customers and employees have different phones. Some have the latest iPhone with a very strong enclave inside, and if everybody had that phone, then we could reasonably say, okay, maybe we can use the iPhone enclave and we feel okay with that. But not everybody has that, and it also only provides very specific functionality. With Unbound, you get a unified platform and a unified API no matter what phone they're using. It doesn't matter if it's Android or iPhone, and it doesn't matter if it's Samsung or Huawei or whatever other manufacturer it is. They'll all have strong protection, and when there is a secure enclave inside the phone, then Unbound will also utilize that as well. So it will give you even better security. And that's what the Virtual Enclave SDK does. The Virtual Enclave for Enterprise Workstations is a similar thing, but when you think about a user's laptop or personal computer, here it's a virtual smart card. We want to enable an employee to carry out cryptographic transactions. In the past, we could have given them a smart card, but that comes back to the problem of hardware tokens. How do we deliver that smart card to every new employee? They have to physically come and get it. What happens when they lose it? What happens when it gets broken? Sometimes connecting it can be challenging, even though it can be USB, but now we're not using USB, or maybe we want to disable USB on some machines because of the security threats. And a software solution has a lot of advantages. The problem is that once we put a key on the laptop or the personal computer, again, it becomes vulnerable. Same story again. How do we protect it? Now it's not between a mobile and a server, but rather it's between a workstation and a server. And then that enables you to provide a virtual enclave on any enterprise workstation for employees and the like, and get strong cryptography also in those settings. So in short, Unbound Core's authentication use cases relate to an SDK for mobile and for enterprise workstations, enabling you to get strong cryptography on any device, essentially, for authentication and for signing on transactions. It's important that that's an additional layer. So SMS Otp and OTP from a hardware token only gives the authentication piece, but what about signing on the transaction with non-repudiation? It certainly doesn't give you that. But with Unbound's mobile situation, mobile SDK, you can sign on transactions with non-repudiation and without the fear of having the key being stolen. And finally, it's important to note that Unbound Core is the only management system that will enable you to manage keys on what we call the server side, so in virtual HSMs and physical HSMs and cloud KMSs, and also user keys on mobiles or on workstations in one management platform. Until now, those were considered to be completely different worlds and had to be managed and dealt with completely differently, but Unbound Core will manage them all in one place.